Hello, students. Hi, a very good evening. Yes. So we have Gungun Tagore here, Diksha Sharma, Himani Arora. Yes. Yeah. Hi, Anil. Hi, Puneet. Hey, Jayashri. Hi, Himani. Yes. All right. A very, very good evening to all of you. Yes. Hi, down to UP. Hi, Harini, Anil, Yashi, R. Raghul, Mehak Kumari, Gungun Tagore. Sri Lakshmi, hi Anush, good evening AK, hi MS Harshan, hi Ayan, good evening Harsha, yes, Amit Mishra, Tia Jain, hey Raj, hi Aditi. So, very, very good evening to all of you. So, there is no glitch at all, yes? I'm audible and visible to everyone. All right, all right. So we can continue. My name is Khushbu and a very, very warm welcome to yet another wonderful session. So we know what today's session is about. Yes? Today we are going to discuss 10 most important NCERT questions of surface areas and volumes. Yes? This is one of the most awaited session. For quite a long time, I remember you all have been asking me, ma'am, please come up with a session on surface areas and volumes. So today, I have come up with 10 most important NCERT questions. So even if you are done with the NCERT, even if you have done this chapter thoroughly from your NCERT, but you want to do a quick revision, you can just go through the important questions now. Yes? Yes, Sonali, I am excited too. Yes, Gungun. What is the CBA? What is it? Yes? No, Yashi. Yes. Yes, Hari Murali. You have this chapter, right? So that's what I'm saying. You can do a quick revision instead of going through the entire chapter now. All right, all right. So before I start off with this, do you remember I gave you a homework question last time? Yes? Now let's just take a quick look at who all actually replied to that. So Diksha Sharma, Ayush Biswas, Fenil. I think Fenil was the first one to respond. Paheli, Tanishi, Charvi, Aditi, Disha Bhatt, Nupur, Divyanshi, Bandana, Bhagyavardhan, Anvisha, Nikesh, Hari, Amrendra Kumar, Harry, Munmun, Gungun, Sukhjot, Puneet, Preetam. I'm sorry, it's not possible for me to read out all the names. I hope you understand, right? Yes? Yes, hi Astha. I'm sure that you would love this session. Yes. All right, all right, all right. Yes. So, for the ones who just want to cross check what the homework question answer is and what is the proper way of writing, let's just take a quick look at this. So, is it possible to design a rectangular mangrove whose length is twice its breadth and the area is 800 meters square? If so, find its length and breadth. So, we already have its area, right? It's 800 meters square. Question says length is twice the breadth. Let's say if length is breadth is x, so length is going to be 2x in that case. So simply it would be x times 2x equals to 800. So x square would be 400, x would be plus minus 20. It cannot be negative, right Sonali? So because we accordingly we pick up the values. Here x is representing the distance. It's representing the length over here. So it can't be negative, so x would be equals to 20 in this case. So breadth is 20 meters, so length is going to be 40 meters. Yes? So I'm sure that now you have no confusions in such things, right? When it comes to picking up the values, right? Absolutely, Hannah. 20 and 40. Yes. Thank you so much. Yes, Sonali. I still remember, yes. This was your doubt in the previous session also. I remember that. This is not, no Hazina PA. This is not the first question. This was the homework question which I gave in the previous session, quadratic equation. So we were just discussing the solution, the answer. All right, so now we will start up with surface areas and volumes. First, let's take a quick look at the syllabus. See, area of combination of solids we have in this year's syllabus, volume of combination of solids and conversion of solids. Frustum of a cone is deleted from the term 2 syllabus, right? So we do not have to prepare this. We will only be talking about these 3 topics. Yes. So, Ananti, these are the important questions from, like questions which are important from exam point of view. Yes, Kishanani, yes, thank you. All right, all right. So let's not waste any more time here. Let's start the session. Here is the first question. So medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeters and the diameter of the capsule is 5 millimeters. Find its surface area. You can see this capsule over here, right? You can see that it is cylindrical. Plus, it has 2 hemispheres attached at its 2 ends, right? Okay. So, question says we have this entire length. Entire length is what? That's 14 millimeters, entire length. But the diameter, you see the diameter for the cylindrical part and the hemispherical part, that is common, right? Right, so that is common. So diameter is 5 millimeters, so radius would be 2.5 millimeters for the hemisphere as well as the cylinder. Okay, so now when it comes to finding out the surface area, so don't get confused, we are talking about the entire surface area, total surface area of the new solid. What will that be? So we are talking about a capsule over here. We all have seen the capsules in real life, right? You might have taken it as well. So how is it? We have a cylinder and then the 2 hemispherical ends. So we will consider the curved surface area of both the hemisphere and curved surface area of the cylinder. I hope no one has confusion, nobody will have confusion in this, that why are we considering the curved surface area? Why not the total surface area? Yes? Yes. Right, Sonali. So this is clear? I think no one has confusion in this. Wow, Siraj, amazing. See, even during the sessions, because now I'm familiar with most of you, because those, especially those who are regularly attending the classes, and I can see that, I'm not just taking a particular, I'm just saying that. Some of you, I can see that who are actually practicing very hard. Yes. Thank you, Kira. So what is the curved surface area of cylinder? That's 2 pi RH and curved surface area of hemisphere is 2 pi r square. Okay. So simply diameter of capsule is 5 millimeters, length is 14 millimeters, radius would be 2.5 millimeters. Right? Now, so curved surface area of hemisphere 2 pi r square. Put all the values, pi is 22 by 7. You get 275 by 7 millimeter square. That's the curved surface area for a hemisphere over here. Yes. So the total length of the cylinder, if you talk about here, total length would be for the cylinder. This entire length is 14 millimeters. So here this much length and this much length. This is 2.5, 2.5. So I'll subtract twice of 2.5 from this 14. We get 9 millimeters. Yes. Thank you, Yuvraj, for such kind words. I'm glad that you're actually liking it and it's actually fruitful for you. So I can see that many students are saying we have doubts, we have confusions in this chapter. See, I'm discussing the important questions. Moreover, these questions are covering each and every topic as well. So please pay attention to this. I'm sure that by the end of this session, you would love this chapter. Yes. All right. So now we have what? This 9 millimeter is what? This is the length for this cylindrical part. Right? No confusion still here? Okay. So what we will do here, we will find out the curved surface area for this cylinder now. That's 2 times 22 by 7 into 2.5 into 9, 22 by 7 into 45. So 990 by 7 millimeter square. That's for this cylindrical part. Now coming to this, the required surface area. So that would be twice of the surface area of one hemisphere. Surface area of one hemisphere is what? 275 by 7 millimeter square. For this one also, right? That's why we are multiplying by 2 plus CSA of the cylinder, add them up, you get 1540 by 7 millimeter square, which is 220 millimeter square. Absolutely, Hannah, Anil, right? Siraj, yes. 70.71. How come, Garuda Gaming? How come you're getting 70.71? Please solve this question. Yes, I've shown you the solution. We have solved this question. What do you want me to solve now? So Nali, about the next session, I'll tell you. I'll tell you at the end of the session. Don't worry. First, Please focus. Please concentrate here. What I'm teaching right now. AK 219. You see, answer is 220 millimeter square. Many students are getting the same answer and you have the same question in the NCERT. Even the digits are not changed. So if you're getting any other value, yes, you can round it off. AK. Now your message is visible, Gungun. Yes. I hope everybody is getting the same answer now. 220 millimeter square. No doubt still here. Right? Shall we move ahead? Okay. 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 All right. So let's move to question number 2 now. So a tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meters and 4 meters respectively, and the slant height of the top is 2.8 meters, find the area of the canvas used for making the tent, also the cost of the canvas of the tent at the rate of 500 per meter square. Note that the base of the tent will not be covered with canvas. Okay. So here we are talking about a tent, right? So this tent has a very unique shape. It is cylindrical at the bottom and then it has a conical top over it, like you can see over here. So this cylindrical part, its diameter is given, that's 4 meters. Its height is given, that's 2.1 meters. And the conical part has a slant height of 2.8 meters, right? So obviously they are sharing a common base. So definitely the radius for both of them is going to be same, right? Yes. Absolutely, Midil Nair. Yes. Right. Okay. All right. So to simplify this, what we will do here is simply to find out the TSA of new solid, we will take CSA of cylinder and CSA of cone. Question has already mentioned that tent, obviously, it will not be covering the base, right? Even if it might be possible that this note will not be there in your paper, right? But see, it is common sense that obviously when we are talking about a tent, it is never on the floor. Yes. So definitely we will not be covering the area of this floor over here. And definitely this part will also be open since it has a conical top over it, right? So that's why we are considering the CSA over here. Right. So curved surface area of the cylinder is 2 pi RH and curved surface area of the cone is pi RL, right? All you need to do is diameter is 4 meters, right? So here slant height is 2.8 and height of the cylinder is 2.1. Radius would be 4 by 2, that means 2 meter. No confusion still here, right? This is simple. Now what we will do here is simply we will find out the surface area of the tent. That is CSA of cone plus CSA of cylinder. Put the formula here. So what I prefer to do it this way. That first we take common from here. Since both of them have got pi common and radius also common. So inside we have L plus 2H. Put all the values, you get 44, 7 times 7, you get 44 meters square. Absolutely AK. Gaming green world. So simply आपको क्या करना है CSA कोन का CSA सिलेंडर का राइट कर्व सरफेस एरिया आपने उनको लिया उनका फॉर्मूला पुट किया सारी वैल्यूज सब्स्टिट्यूट करी आपके पास आएगा 44 मीटर स्क्वायर ये सरफेस एरिया आया है टेंट का राइट एब्सोल्युटली सोनाली राइट नाउ व्हाट वी नीड टू डू इज वी हैव टू फाइंड आउट द कॉस्ट ओवर हियर राइट so we are given the cost per meter square is 500 so overall cost would be simply I'll multiply by 500 I get rupees 22,000 राइट गेमिंग ग्रीन वर्ल्ड सिंपली आपने कॉस्ट को मल्टीप्लाई करना है एरिया से क्योंकि पर मीटर स्क्वायर इज 500 यू गेट 22,000 rupees. Finding statistics difficult. That's one of the easiest chapter. Yes, isn't it? And I remember I did a session, one short session on statistics. And students have really liked it in fact. And in fact, if you see, there we have explained things so nicely. Also, see, there are only few formulas in statistics. I would suggest you please watch that video once. I'm sure all your difficulties, all the doubts that you have in your mind will be cleared. Puneet Kaur, yes. Hannah? Yes. I hope this question is clear to everyone. Any doubts still here? Quickly give me thumbs up, smileys or hearts so that I know that I can move ahead now. Absolutely, Ragul. Yes. Aditi, yes, ma'am. Soumya, okay, ma'am. Yes, ma'am. Clear. Learning India, no. Why? What happened? Yes, Preetham. Alex is there. Yes. Yes, I can see lots of smileys, hearts, and thumbs up. Wow, amazing. Yes, Learning India. Any doubt? So, may I'll answer to this question at the end. Yes. Thank you, Astha. Nagavini, I'm sure you would love this session. Thank you. Adarsh Gupta, what could you not understand? Quickly, just tell me the step number that you have, where you have the doubt. Gayatri, Learning India. Yes. Adarsh Gupta, which step? Simply the question is saying we are talking about a tent and it has a shape where it has a cylindrical bottom first and there is a conical top over it, right? So obviously the cylindrical bottom and conical top, they have a common base. So radius will be common for both of them, right? Yes, radius would be common. So, and the conical one, curved surface area is what? When we do not consider the base, right? This part is open over here. There is a cylinder and a cone over here. This part is open, right? It is not closed. That's why we are considering the curved surface area for both of them. Moreover, question says there is nothing at the bottom. So we will not consider the base also. We are only considering the curved surface area for both of them. Yes? Others, second step. Yes. So simply I'll put the formula pi r L plus 2h. Only we have to substitute the values here. This is simple. You get 44 meters square. Coming to step number 2. Question is saying the cost per meter square is 500. Right? So per meter square cost is 500 rupees. And what is the total area? That's 44 meters square. So to find its value, to find the total cost, I'll multiply with 500. Yes? You get rupees 22,000. Adarsh, I hope it's clear. Yes? Learning India. Yep. Thank you, Rahul. Why we are finding CSA, why not TSA? Yeah, that's what I asked you in the beginning. Why CSA? See, imagine have you ever stayed in a tent? Have you ever seen it? Yes. There is never. See, even if this line is not mentioned in the question, probably in the paper it will not be mentioned. Tent is never on the bottom, right? So we have a cylindrical tent. If you have you seen a circus tent? You have seen that in movies also, right? So there is a cylindrical tent and at the top of it there is a conical part, right? Conical tent. So this is not closed here. It is open. This is the reason we are considering only curved surface areas, not the total surface area. Yes. Only one side. Tanveer. Yes, Astha. Yes. What doubt? CSA or TSA? What is it? I explained this thing. Why CSA? Yes. I hope this is clear to everyone now. Shall we move ahead? Varun, conical part only CSA? Yes, conical part only CSA. Reason being, it is not closed here. It is open. Right? Because if you talk about, if you have seen this kind of tent or ever seen in a movie or if you have seen it, even the question, had it been closed, question would have specified it. Nothing is mentioned here as such. All right, all right, all right. So this is the final answer. All right. All right, let's move ahead. Let's take a look at question number 3 now. So now this is a question that I want you all to try. So from a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. 4 options you have here. Try this question and I'll give you 60 seconds to solve this. And I'm starting the timer now. Quickly solve this. Yes, Varuna, we are on the next question only. Now you solve this question first. Hannah has given the answer. She says it's B. It's D, sorry. It's D. Okay. So Hannah is the first one to reply. Let's see what the right answer is actually. Harshit also says it's D. Amazing speed. You both solved it so quickly. Yes. Learning India also says D. Nikesh, D. Sonali. Yes. D. Mostly students are saying it's D. Versatile image, Learning India, Soumya, Divya, Aditi, Gungun, Sushil Kumar. All right, all right. Time is up. Okay, let's check what the right answer is. So right answer is yes, option D, that's 17.6 centimeters. Wow. So all of you have given the right answer, but still let's take a quick look at the solution, that how you have to represent it, right? So once we are talking about a solid cylinder over here, right? So it is filled from inside, completely filled. So question says that a conical cavity from this has been hollowed out and it has the same height and the same diameter. So diameter is same, that means radius would be same. Both cylinder and cone will have the same radius. They are sharing the same height, that is h. Okay. Now find the total surface area of the remaining solid. So once the conical part is hollowed out, what is the TSA for the remaining solid? Okay. That's going to be CSA of the conical cavity plus CSA of the cylinder and area of base of cylinder. So I think all of you have given the right answer, so no one has confusion in this. All right. So simply, we will first convert diameter into radius. We got 0.7 centimeter and height for both of them is same. That's 2.4 centimeter. All right. So now what we will do is first we find out the slant height. That's going to be square root of h square plus r square. That's 2.4 square plus 7 square. 5.76 plus 0.49. That's square root of 6.25. Conical cavity means the cone part only. Yes. Cavity, since it was hollowed out, it was removed from it. You can just say the conical part. Why do we need to add base? Good question. L is 2.5 centimeter. That's the slant height. Okay. So Varuna, your question was why we should have to, okay, why we need to add base. This cylinder is solid. By solid cylinder, you mean, let's say it is completely filled. The top is also, this is also closed. This is closed. Inside it is filled completely, right? Let's say it is completely filled with, let's suppose it is completely filled with sand, right? So this time when I remove the conical portion from it, right? So this will be formed. This will be left. Leftover portion would be like this that I'm highlighting here. Imagine in your mind, right? If you remove this part, what will you have? So this portion is hollowed out now, right? I need to find out the rest of the part. For rest of the part, we have the CSA of cylinder, right? The CSA of cylinder you have. Yes. Also, you have this top, which is actually closed, right? So that's area of base over here, right? And since we are talking about the area, so we need the area of this surface as well, right? This surface. That's why we'll add up the CSA for the cone also. CSA of this conical part. I hope this is clear. So Nali has understood. Yes? Yes, Hannah, because it's total surface area. Because question ने यहाँ पे specify किया है आपको कि ये solid cylinder है. तो अगर ये solid cylinder है, तो completely filled है. Top से लेके bottom तक completely filled है. So when you take out the conical parts, जब आपने वो बाहर remove कर लिया, what is left? क्या बचता है? आपके पास curved surface area cylinder का top लेना है because वो closed है. And ये surface चाहिए because we are talking about the area, right? इसलिए we have to add all these things. I hope this is clear to everyone now. So CSA of conical cavity, CSA of cylinder, area of base. Yes, Deepa. Quickly, you can write your doubt. What is it? Aditi cleared. Yes, Pranav. Learning India, Gungun, Puneet, clear. Great. Yes. So simply I'll put all the formulas. What is common here? They have a common radius. So let's take pi r common. So we have L plus 2h plus r. Right? Okay, let's put all the values here. Whatever you have, you get 17.6 centimeter square. That's the total surface area of the remaining solid. Absolutely, Siraj. You're getting the right answer. Kathambari, yes. Please, rather than writing that you have a doubt, please straight away write the doubt that you have. Because there is a lag of few seconds, right? Varuna, clear? Yes. Yes, Hannah, you have to take pi r common. The calculation becomes simpler if you take common at this stage. Yes? Clear? Learning India, next. All right. Let's move ahead. Let's take a look at question number 4 now. So a wooden article was made by scooping out I'm sorry, someone has a doubt here. Let's take the doubt first. Astha, why we take base area of cylinder? Okay, let's just go back to the previous question first. Once the doubt is clear, we will move ahead. So why we are considering the base of the cylinder? Because it's a solid cylinder. What do we mean by solid cylinder? Which is completely filled. The top is also closed, bottom is closed. It is completely filled from inside. That's what solid cylinder means, right? So here, when the conical part was hollowed, it was removed out, still, this part was still closed, right? That's why we are considering the one base here. Ankita, ma'am, why we add this curved surface area? Okay. Why we are adding the curved surface area? So when you are saying curved surface area of cylinder, right? Curved surface area of cylinder means it doesn't include the top and bottom, correct? So that we have taken. What do we need? We need the top also, right? Because when you hollow it out, this much part is removed. This part is removed, but still the top is there, right? So we have the area of one base of cylinder, and we need this surface as well. That's why we are adding the CSA of conical cavity. Varun, understood? Yes. Top circle remain. Yes, top circle hai. It will remain there, na? Because it's a solid cylinder. Absolutely, Jayashree. Even if you don't take common, you will get the same answer, but it will be more time consuming. This is the easier method. Siresha, we can take TSA now. No. TSA. See, if you take the TSA of cylinder, in that case, you will have to subtract one base, right? Plus CSA of cone. That would be, this is the other way to do it. If you want to do it that way, it can also be done. But in that case, remove the base plus CSA of cone. Yes? All right. I hope it's clear to everyone now. Yes? All right. Okay. Let's move ahead. Let's take a look at question number 4 now. So wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown. If the height of the cylinder is 10 centimeter and its base is of radius 3.5 centimeter, find the total surface area of the article. So you can see this figure over here. We have a solid cylinder. It's a solid cylinder, please. Focus on these words. Solid cylinder means top is closed, bottom is closed, completely filled, right? It's completely filled. It's a solid cylinder. So wooden article is made by scooping out hemispheres. So these two hemispheres you can see over here, they have been scooped out, right? They have been removed. So height of the cylindrical portion is given, that's 10 centimeter, and base radius is 3.5. Now again, cylinder and hemisphere will have a common base. Yes, they will have a common radius. Scooping means, let's say you're removing it out, like you scoop out the ice cream. So you remove it, right? You take it out. All right. Yes. So to find out the total surface area of the article, see, I tell you something. Had question would have asked here volume instead of area, it would have been very simple. From the total volume of the cylinder, we would have subtracted the volume of two hemispheres. But when it comes to area means you need that surface. So what we will do here is, simply to get the total surface area of the remaining figure, we will take the curved surface area of the cylinder, right? Curved surface area of the cylinder plus 2 times the surface area of the hemispheres. Once you take this, then you will get the remaining figure, right? I hope this is clear to everyone. So curved surface area of cylinder means we are not considering top part, we are not considering bottom part, but this has been scooped out. So when I say curved surface area of cylinder, that means I'm not considering this upper surface, I'm not considering this bottom surface. Rest everything is there. It is completely solid. But when I say that 2 times the surface area of hemispheres, that means I need the surface area, I need the area of this surface, right? So this is how we are going to get the total surface area of the figure. Yes, Gaurav, you have missed 3 questions till now, but that's okay. You can watch the recorded session later on. Right? Right, Astha, absolutely. So CSA of the cylinder is 2 pi RH, curved surface area of hemisphere is 2 pi r. Okay, now it's very simple. All we need to do is, we have the height, we have the radius also, right? All we need is, we just have to use this formula and put everything here. So 2 pi RH is the curved surface area of cylinder, and that's 2 times 2 pi r square. So 2 pi r h plus 4 pi r square, take 2 pi r common, you have h plus 2r. Put all the values, you get 374 centimeters square. Yes, doubts? I think Varuna just said that, sorry, I missed your question. You were saying something that subtraction होना चाहिए because we have scooped it out. But subtract नहीं. Reason, अगर ये volume होता, so we would have done it. कि total volume of cylinder minus volume of two hemispheres. You would get the remaining solid. अगर volume होता तो, right? Because volume is basically matter contained inside something. But it is area. Area means surface. Surface का area चाहिए. So आपने जब scoop out करा, तो ये जो shape यहाँ पर ये this shape that has been formed here. How will you find out the area for this shape? That's why these two areas of hemispheres we have added here instead of subtracting. Yes. Yes, Gungun, we have done a session on formula sheet. It's there on YouTube. You can watch it and the PDF is also available for that session. Siraj has done a lot of practice, seems like. Yes, Ashwini. Thank you, Gaurav. So I hope this is clear to everyone now. No confusion still here. Ma'am, why should we take CSF hemisphere as the whole of the shape is scooped out? Correct. It is scooped out, right? So volume की बात नहीं कर रहे हैं. We are talking about area, right? So we need the area of this line. See, imagine in your mind, if you scoop it out, right? Let's suppose you have a cylindrical ice cream, right? Like you have an ice cream brick. Let's say it is in the shape of a cylinder this time. You scoop out two hemispheres from the ends. So obviously this shape would still be there, right? You need the area, you need that surface. So to find the area of that surface, we have added the CSA of hemispheres, right? CSA doesn't cover this thing. It is not covering this thing. It is only covering the outer part, you see, only outer covering. Yes, clear? Thank you, Hannah. Right, Ankita? So, Ankita, what we have done here is CSA cylinder ka curved surface area. Solid cylinder hai, completely filled hai. Let's say ice cream brick is the shape of a cylinder. So, CSA cylinder ka only the outer covering it will take, right? And this has been scooped out. So, we need the area of this area we need. This outer areas. Only the outer covering it is taking. That's why we are adding here. This is clear? Yes. All right, clear. No doubt still here? Yes? Next question. All right, let's move ahead. Let's take a look at question number 5 now. So, gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. Right? Okay. So, we are talking about gulab jamuns here and they have a shape. So, it is basically cylindrical and then two hemispheres at the two ends. Yes. So, total volume of one gulab jamun is basically volume of one cylinder plus volume of two hemispheres, right? That's how. See, volume, when it comes to the question of volumes, they're very simple. They are straightforward, right? Only the confusion that you will have been, it would be the question of areas. So, we will simply take this gulab jamun is like we have a cylindrical part and the two hemispherical parts. So, volume of cylinder plus volume of two hemispheres. Simple one. So, volume of cylinder is pi r square h, volume of a hemisphere is 2 pi 3 pi r. Okay. So, what we will do here is total length of this gulab jamun, which includes the hemisphere as well. That's 5 centimeter. Diameter is 2.8, so radius would be 1.4 centimeter. Now height of the cylindrical part would be what? That would be total length, which is 5 minus the radius of two hemispherical parts. So that would be 5 minus 1.4 plus 1.4, that's 2.2. That's the height for the cylindrical part. Okay, I can see answers. Wow. You all know how to solve this. So total volume would be volume of cylinder plus volume of two hemisphere. Put the values pi r square h plus 2 times 2 by 3 pi r cube. Put all the values here. You get, see in this question, it involves a lot of calculation. This is important also. So all the values that we have here that you get after rounding it off. So 13.55 plus 11.50, you get 25.05 centimeter cube. Yes, that's the volume of one gulab jamun. And sugar syrup is what? That's 30% of the total volume. And we have 45 gulab jamuns here. So what is 30% of total volume? You will get the actual volume of the sugar syrup. And we will multiply that by 45 since there are 45 gulab jamuns. So you get 338.175 centimeter cube. So final answer you can say 338 centimeter cube also. Right? That's also correct. Siraj, Muskan, Learning India, R. Raghul, yes, absolutely. Priyam, Ramanand, Hannah, right. Right. So 338, you can just write down the final answer. So no confusion in this questions. Yes, Gaming Green Girl, because the session is about 10 most important questions from NCERT. Sonali, one more time. See, this is simple. We have a gulab jamun here, right? And all the height and radius, the dimensions, everything is given here, right? So we are given that the total length for this gulab jamun is basically 5 centimeters, right? Total length. And the diameter is 2.8. So radius would be 1.4. So it is like this. It has a hemisphere. It has the cylindrical part and two hemispherical ends, right? Shaped like a cylinder with two hemispherical ends. So what you will do here is, so radius is 1.4. So this hemispherical part, this is 1.4 and this is also 1.4. So from 5 centimeter, I'll subtract 1.4, 1.4. You get the height of the cylindrical part, that's 2.2. Yes. Why are we multiplying with 45? Varuna, I'll answer to this question. Yes, Astha. Yes, I'm repeating again. So now you have the height for the cylindrical part. That's 2.2. We need that, right? Because I need to find out the volume of the cylinder. Okay. So what you will do is volume of cylinder plus volume of two hemispheres. Simply put all the formulas, right? And put the values here. All the values. You get 13.55 plus 11.50, 25.05 centimeter cube. Yes, Kushal. All right. Sonali, clear? Okay. So this is the volume of one gulab jamun. But the question is saying a gulab jamun contains sugar syrup up to 30% is volume. So in one gulab jamun, the amount of sugar syrup is basically 30% of the gulab jamun's value, right? So what is the gulab jamun's volume? That's this. And what will be the value of sugar syrup in it? That would be 30% of it. So total sugar syrup I have to find out. And there are 45 gulab jamuns. This is the reason we are multiplying this by 45. See, you can do step by step also. First, you find out the volume of sugar syrup in one gulab jamun. That would be 30% of this. Then you find out the sugar syrup in all the 45 gulab jamuns. That would be 45 times this. But that's going to be time consuming. Trust me. Rather, you do it in one step. And you get 338.175. You need to understand these small things. And this you can understand with practice only. That how we can save time in exam. Amit Mishra, I hope you're clear. Yes? Thank you, Chitra. Yes. Gaming Green World. Yes, Asala, absolutely. All right, it's clear to everyone. Let's move ahead. Let's take a look at question number 6 now. Now, it's time that you try this question first. So, a pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimensions of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. The radius of each of the depressions is 0.5 centimeter and depth is 1.4 centimeter. Find the volume of wood in the entire stand. So 4 options you have. I'm giving you 60 seconds to solve this. Start solving quickly. Yes. Let me see who gives the right answer first. Oh my God, Rahul. Rahul says it's A. Siraj also A. Yes. I can see some people are joining now. Hannah, Aditi, Varuna, yes. A. Everyone is saying A. It's okay, Shalini. So you have missed a lot of questions, almost more than half of the session. So you can watch the recorded session later on. That's okay. I think you're still discussing about the previous question. Everybody is saying it's A. Hannah, Garuda, Learning India, Astha, Muskan, Sushil Kumar. Yes. My God, you all have got such good speed. You could solve this question in less than 30 seconds. Amazing. Why? Because this is an NCERT question. Yes. Is that the reason? Okay, time is up. Let's see. Yes, so A is the right answer. Absolutely. All right, but let's take a quick look at the solution now. Yes, it is easy. The questions of volumes are always easy, trust me. So volume of wood in the entire stand would be volume of cuboid minus 4 times the volume of cones, right? Because every time it has a conical depression. Yes? Right. So volume of cuboid is L times B times H. Volume of cone is 1 upon 3 pi r square H. All right. So these are the dimensions. This is the radius and this is the height. So simply we will find out the volume of cuboid. 15 times 10 times 3.5 centimeter. That's 525 centimeter cube. Yes, so this is clear. अच्छा मेरी वजह से इतने तेज हो गए हो. Wow, amazing, nice. Thank you. So volume of cuboid is 525 centimeter cube, and then radius and depth is given, so we can find out the volume of cone. That's 1 upon 3 pi r square h. So 4 cones are there, right? So we will use 4 times of this. Put all the values, you get 1.47 centimeter cube. Yes. Easy one, right, Sonali? Simply I'll subtract them and you get 523.53 centimeter cube. Very simple question. See, I want to tell you one thing here. Since in this question, it was about volume. It was very simple for you to guess that you just have to subtract it since it was taken out. It was removed. But if you remember the question where the hemispheres were scooped out, you had confusion in that because that involved area, right? So when it comes to area and something is scooped out, it's not that you have to subtract it. We're not talking about the volume here, right? We're talking about the surface. Why I'm talking about this thing? Just to, make you understand that there's a difference between area and volume. Right? I hope now you understand the difference. Yes. Ask the 10 questions and all I'll be discussing. This is clear to everyone? Yes? Alright, let's move ahead. Let's take a look at question number 7 now. So vessel is in the form of an inverted cone. Its height is 8 centimeter and radius of its top, which is open, is 5 centimeter. It's filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of water flows out. Yes, find the number of lead shots dropped into the vessel. Okay, so first of all, we are talking about a cone and a sphere here. So volume of cone is 1 by 3 pi r square h. Volume of sphere is 4 by 3 pi r cube. Number of lead shots we have to find out. So we will be using this formula. Let's first take a look at the figure. We have an inverted cone. Yes, inverted cone, and its height is given, that's 8 centimeter. Its radius is given, that's 5 centimeter. It is filled with water up to the brim. That means completely filled with water up to the brim. Till here, yes? Okay. Now, lead shots, they are spherical in shape. They have a radius of 0.5 centimeter. So, when lead shots are put into this, are dropped into this vessel, obviously some water will flow out. Yes? So, question says 1/4 of the water flows out. You must have done this kind of activity so many times, I'm sure. Okay. So, let's say radius of the cone is 5 centimeter, height h1 of the cone, that's 8 centimeter, radius of sphere r2 is 0.5 centimeter. Okay. So, what we can say here is that the volume of water in the cone would be equal to the actual volume of the cone, right? Because it is completely filled up to the brim. So, put the values here, you get 1 upon 3 pi, 5 square into 8. You get 200 upon 3 pi centimeter cube. Yes? So, this is the total volume of water. Okay, in the inverted cone. Now, what happens here? We have to, when we drop the lead shots into it, since it is filled up to the brim, 1/4 water flows out. So what is the volume of water that is flown out? That's 1/4 the volume of cone. I hope this much part is clear to everyone. First, what we are doing here is we are simply finding out the volume of cone. What is volume of cone? 1 upon 3 pi r square h. Right, Sonali? Simply volume of cone. Nothing we are doing here. Now, question says it is filled up to the brim. Think of a conical vessel, right, which is filled up to the brim with water. Now, you put some spherical balls into it, let's say. Water will flow out, definitely. So, it says 1/4 of the water flows out. So, first we are finding out how much water flows out here. That's basically 1/4 the volume of cone. That would be 1 upon 4, 200 by 3 pi centimeter cube. I'm not substituting pi here. Why? Because it will make the calculation simple later on. It will get cancelled out. Right, so we get 50 by 3 pi centimeter cube. Yes, I can see the final answers. That's right. Now, question says that we have a spherical lead shots here, right? So what is the volume of one lead shot? That's 4 upon 3 pi r2 cube. Put the value, you get 1 by 6 pi centimeter cube. That's the volume of one lead shot. Okay, now we have the volume for each and everything. To find out the number of lead shots, I'll divide the total volume of water overflown by volume of one lead shot. And you get 100 lead shots. See, pi will cancel out. No need to put it. Yes? Clear, Sonali? So everyone understands this, right? Why we are dividing them? Because the the cone was completely filled with water up to the brim. You put the lead shots, water flows out. But I don't know how many lead shots they have put here, right? So to find that out, simply what we have done here is, let's say the number of lead shots over here are X. We have multiplied that with the volume of one lead shot, right? That would be equal to the volume of water flows out. This is what we have done. Right? Yes, Harry. Yes, Harshit. You want me to repeat? Is that so? Yeah? Okay, so what we are doing is, we have a cone. It is filled with water up to the brim. Now we are putting some lead shots into it. When you drop the lead shots into the vessel, we don't know how many lead shots we have put, but 1/4 water flows out. So we know the Archimedes principle. The amount of water that will flow out will be equal to the volume of that particular object. Same thing we are doing here. Let's say the lead shots over here are X and the volume of one lead shot we have find out. So if I multiply that, the number of lead shots with the volume of one lead shot, that would be equal to the amount of water that flows out. Yes? So you get this value at the end. So this is basically, in one line, I would say this is the concept that I have used here. Anna, clear? Yes, Pramod, Surinder, Art World and Songs Gallery. Muskan, I have repeated it. Yes, Harshit, I hope it's clear now. Yes, Muskan. Yes, Sonali, right. So basically the physics concept we are using here, right? The amount of water that flows out depends on the volume of that object that was put into it. Learning India, Henna, Puneet, learning, yes, Siraj, Varuna. Clear. Quickly, if I've understood this, thumbs up, smileys, hearts. Yes. Pramod, ma'am, it's clear. Varuna, Muskan, yes, ma'am. Learning India, Gungun Tagore. Harshit, yes. Sonali, clear, ma'am. All right, all right. Yes. Astha, not clear. Where do you have confusion? The basics. See, I'm sure that nobody would have confusion in this. How to find out the volume of a cone or a volume of a sphere, right? That is simple. Only the concept you need to understand. So this is completely filled with water. Let's say, take a glass of water. You can do it right now. Take a glass of water. Fill it up to the brim, right? Now put anything into it. Let's say you are putting erasers into it, right? So amount of water will flow out. So the amount of water that will flow out, that will depend upon the volume of that object which you have dropped into the glass of water, right? Same thing we are doing here. So let's say the number of lead shots, we don't know here. Let's say that is X, right? Into the volume of one lead shot, right? So this is the total amount of object that we have dropped into the vessel. So that will be equal to what? The amount of water that flows out. So volume of water that flows out, right? Yes. Cookie, Mohammed Sahil, clear, clear, clear. Yes, Astha, Harshit. I hope nobody would have doubt in this now. Yes. Sonali, clear, yes. Surinder, Akshat, Kushal, Henna. No, it's not clear. So which step? Which step? Step number, this is step number 4. Where do you have confusion? Varuna, yes, clear. Okay. I'm waiting. Quickly tell me. Nikesh, Madhvi, Nitik, Walking Kid, Astha. Okay, I can see big smiles now. Okay. Henna, Kishore. All right. Clear, yes? Okay, great. All right, awesome. Let's move ahead. Let's take a look at question number 8 now. So, a container shaped like a right circular cylinder having diameter 12 centimeter and height is 15 centimeter is full of ice cream. So, we are talking about a right circular cylinder here. It's full of ice cream up to the brim. Yes. The ice cream is to be filled into cones. We all have seen ice cream cones, right? We are filling ice cream into the ice cream cones and they have a height of 12 centimeter and diameter 6 centimeter. It has a hemispherical shape on the top, right? Find the number of such cones which can be filled with ice cream. So what we have here is we have a cylindrical shaped, right? We have a cylindrical shaped container and it is completely filled with ice cream. Okay. It is completely filled with ice cream now you can see, right? Now we have to fill ice cream cones with it. These are the ice cream cones. Once I start filling the ice cream cones, so obviously they will have hemispherical top on that. Yes, like this. We are filling the ice cream cones. I don't know how many ice cream cones can be filled with this ice cream. So the complete amount of ice cream, the complete volume of ice cream we are going to use. Right? So you need to find out here the number of cones. How many cones can be filled? So what we will do here, simply, we don't know the number of cones here. So number of cones, basically ice cream cones, into the volume of one ice cream cone would be equal to what? The volume of this cylinder. So this is the concept. This is the concept that we are going to use in this question. Yes, Akshat, understood. This is clear to everyone, right? If this is clear, so almost half, I would say half of the question is done. Now we just have to use the formula, put the values here. Mishra ji, yes, ma'am. Rahul got the answer. Nikesh. Jayashree is giving thumbs up. Yes, Tanu. Walking Kid. Yes, 10 cones. Any doubts still here? Absolutely, Varuna. Similar to last concept, you can say. Yeah. Yes, Tanishq. Yes. Navneesh. So, no. Okay, Puneet, no ma'am. Okay. See, so we have a cylindrical vessel, right? Cylindrical shaped container. It is completely filled with ice cream, right? Now, we have to fill ice cream cones with it. We all have seen ice cream cones. So, we will scoop out ice cream from the cylindrical container and we will fill the ice cream cones completely with it. I don't know how many cones can be filled. How do I find this out? So, the number of cones, I don't know what the number of cones here are. If I multiply that with the volume of one cone, right? So that would actually give me what? That would give me the total volume of this cylindrical container, right? Makes sense? Yes? Navneesh, okay. That's okay. You understood. Okay. Puneet Kaur, no doubt. Oh, I can see big smiles over here. Yes. Okay, you mean to say clear? No doubt. Okay. Because you said no. All right. It's clear to everyone. Great. So these are the formulas: volume of cylinder, volume of cone and volume of hemisphere. Now we all know it. This is what we are going to use. So height of the cylindrical container, that's H1, that's 15 centimeter. Radius is diameter by 2, that's going to be 6 centimeter. R2, which is for the ice cream cone, that would be 3 centimeter and H2 would be 12 centimeter. Make sure, since they all are different, you have to denote them by different variables. Yes, this is important. Yes. Nagavani, yes. Atif, sorry, I could not read your comment. Versatile mage, no doubt, great. Yes, Atif, please kahiye, yes. Sandhya, no doubt, okay. If we write answer in pi in exam, then it would be okay or not? Absolutely. You are saying the final answer, not the final answer, right? Obviously, at the last, you would put the value of pi and give a proper final answer in numerical values. But in between, when we are solving, we can use pi. Your marks, obviously, it will not be deducted. You're not doing anything wrong. It's absolutely right. Yes. Varuna, no doubt? Okay. Uh, okay, Atif. So what we are doing, what we are doing here is simply आपको क्या करना है यहाँ पर एक cylindrical container है, completely ice cream से filled है, and इससे we are filling ice cream cones. So we will scoop out the ice cream from the cylindrical container and we will fill the ice cream cones completely with it. So now I do not know how many cones will be filled with it, right? But we are going to empty this entire container. So we don't know the number of cones, but we can find out the volume of one cone. So if I multiply the volume of one cone with the number of cones, I'll get the total volume for this cylinder, right? This is what we are doing here. So simply, these are the radius and the heights for both of them. We will use it, and simply I can say volume of ice cream in cylinder would be equal to n times the volume of base of cone plus volume of hemispherical top. That's what we are doing, right? Volume of cylinder would be pi r1 square h1. Okay. Pi times 6 into 15. See, I have not put pi here. I'm using it as it is, right? That's 540 pi centimeter cube. This is the way to do it. You can do this and you should do this way only. It will save your time. So volume of one ice cream cone. So ice cream cone has this conical part and the hemispherical part on top of it. So for conical part, it's 1 upon 3 pi r2 square plus h2. See, I'm denoting with different variables, r2, h2. You cannot use the same variable since they have different values. So 1 upon 3 pi as it is, 32 times 12, you get 36 pi centimeter. Right? Okay, so volume of hemisphere, 2 upon 3 pi r2 cube, 2 upon 3 pi, 33, 18 pi centimeter. Total volume for this ice cream cone is what? 36 plus 18 pi centimeter cube, that's 54 pi centimeter cube. Yes? All right. All right. Now, Sonali, it depends. Yes, it depends. So, but question says that it's having a hemispherical shape on the top. So we have to consider it, right? That it has a hemispherical shape. So we'll solve accordingly now. So simply we will divide them. We get 540 pi by 54 pi. You get 10. Number of ice cream cones would be 10 here. So 10 cones would be your answer. Yes, Muskan. Mr. Zain, Varuna B, Sandhya, yes. Yes, Gungun, Atif, right? Okay. It's clear to everyone? No doubt still here. Yes? Nikesh, Atif, Nitik, Dilip Nair, Muskan. Quickly, thumbs up, smileys, hearts, that I can understand that it's clear to all of you. Gungun, yes. Varuna, understood, ma'am. Atif, yes, ma'am. Thanks. Aditi, yes. Clear. Sana, Jasmine. All right. Amazing. Okay, let's move ahead. Let's take a look at question number 9 now. Okay, I can see smileys and thumbs up now. Wow. Awesome. Now it's time for you to solve this question. So it says a cylindrical bucket of height 32 centimeter and base radius 18 centimeter is filled with sand. The bucket is emptied on the ground and a conical heap of sand is formed. The height of the conical heap is 24 centimeter. Find the radius of the heap. And you have 60 seconds to solve this question. Let's start the timer. Yes. What happened, Hari? Network issue. Oh. Annapurna, thank you. Ragul, again, Ragul is the first one to answer. Then Abhishek Kumar says 36. Okay, first. Varuna B, A. Sonali says easy peasy. Oh, really, Sonali? Versatile Mage, Nikesh, yes. All right. You all are so fast. You are able to solve this question in such less time. Although this question would take, actually it will take 1 minute to solve because it involves calculation as well. Yes, Abhishek Kumar, 2 seconds. Wow. So time is up. And the right answer for this question is, yes, it's a 36 centimeters. So you all know how to solve this. Yes? Okay, but let's take a look at the solution. Thank you, Annapurna. So, we have a cylindrical bucket, its height is given and its radius is also given, right? It's completely filled with sand. Now it is emptied on the ground, you can see, and it will form a conical heap of sand. Yes. And it has a height of 24 centimeter. We need to find out the radius for this heap. So the volume of cylinder is pi r square h, volume of cone is 1 upon 3 pi r square h. Yes. So radius of the bucket, we will denote this by r1 18 centimeter, height h1 32, h2 is 24 centimeter. We are using different denotions for each one of them, right? Make it a point because you cannot use the same denotion. That would be wrong. So volume of sand, total volume of sand in this bucket is pi r1 square h1. So that's pi 18 square times 32. See, I'm keeping pi as it is. It will make the calculation simpler. That's 10,368 pi centimeter cube. That's the volume of sand in the cylindrical bucket. And then let's say the radius for this conical heap is r2. So this is the volume for the cone. And we will keep pi as it is again, and we get 8 pi r2 square centimeter cube. Yes. Alright, so what we will do here is we are just going to equate, because volume will not change. You remember I told you in this when we had a session on surface areas and volumes. And whenever you come across such word, then something is broken into or it was recasted, melted, you come across and questions and it is emptied. Entire bucket is emptied. So obviously in that case the volume will remain the same. So this is the actual main concept that we are using here. Rest is only formulas and calculation, right? So just equate them, cancel out pi, and you get R2 equal to 36 centimeter. That's the radius for this conical. So I hope no one would have doubt till here. Easy question, yes? Sushil Kumar, yes. Abhishek, Gungun, right. Eric, Akash, yes. All right, all right. No doubt, clear ma'am, Puneet, thumbs up. Okay, okay. All right, so I think no one has doubt till here. Yep. Muskan, no doubt. Hannah, clear. Sandhya. Nagavini, that's good. All right, clear. Great. Let's move ahead. Let's take a look at the last question of today's session. Question number 10. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meters deep. If water flows through the pipe at the rate of 3 kilometers per hour, in how much time will the tank be filled? Yes. So, here we are talking about there is a farmer. He has connected a pipe, right, which has a diameter of 20 centimeter from a canal into a cylindrical tank, and which is 10 meter in diameter and 2 meters deep. Okay. So what is the volume of cylinder? He has connected that into the cylindrical tank, right? Cylindrical tank, it has a diameter of what? Diameter of 10 meters. So radius would be what? Radius would be 5 meters in that case. So he has connected a pipe, right? Water is going here. Sorry for my drawing. So the field over here, it says water flows through the pipe at the rate of 3 km per hour. In how much time will the tank be filled? And here he has connected the pipe of internal diameter this. And this pipe has a diameter of 20 centimeter, right? And the field over here, right? The field is also given. Now, question says that internal diameter for the pipe is 20 centimeter, right? So the radius, that is R2 over here for the cylindrical tank, obviously that's going to be 5 meter. Depth of the tank is basically 2 meters, right? For the cylindrical tank that I'm talking about. Radius is 5 meters. The depth over here is 2 meters. Yes. Okay, I can see answers over here again. All right. So he has connected a pipe over here. Through what? The water is flowing through the pipe. Pipe has a diameter of 20 centimeter. So 20 centimeter, to convert it into radius, I divide by 2. Since it is in centimeter, I'll divide that by 100. We have 0.1 meter. So that's R1. Now, the water is flowing through the pipe at the rate of 3 km per hour. Here comes the important step where mostly students have confusion. So now it all depends on the dimensions of this pipe, that in how much time is it going to fill the cylindrical tank. See, think about it. If you have a narrow pipe in your hand, a narrow pipe, then obviously it will take more time to fill the cylindrical tank. But if you have a broader pipe with a big diameter, it will take lesser time. So I have the diameter, we cannot change it, but I do not have the length. This pipe is also cylindrical in shape. I do not have the length. So this speed over here, that's 3 km per hour. From here we will get the length. So area of cross section, that means this is the area of cross section, the circular part for the pipe. That's pi r1 square, 0.2 square, that's going to be 0.04 pi meter square, right? Now speed of water, that's 3 km per hour. So 1 kilometer is equal to 1000 meters. So 3000 meter by 60. On cancelling it out, we have 50 meter per minute. Right? So in 1 meter, how much amount of water flows? You would say 50 meter water flows, right? But if you talk about the volume, that's basically what? Pi r square h. So simply that's 50 into 0.01 pi, that's 0.5 pi meter cube. So we get the volume of water that flows through the pipe in 1 minute actually. Yes. All right. So जो pipe दोनों see they both are cylindrical. आपके पास जो tank है वो भी cylindrical है, जो pipe है वो भी cylindrical है. Cylindrical tank के dimensions are given in the question. But if you talk about the cylindrical pipe, you have only the diameter for that. You don't have the height, you don't have the length. So speed को we can convert into length and you can find out the volume. Yes? Yes? Any doubts? Yes, Sonali, I have repeated one more time. Any doubts still here? Yes, I know that students do get stuck in such questions. That's why I'm asking again. Aditya, no doubts. Okay, Nikki. Anyone has a doubt till here that how are we converting this speed into the length? See, this is very simple. Question says 3 km per hour. So basically in 1 hour it covers, because water will flow along the length. It is covering 3 km distance. So in 60 minutes, obviously it will cover 3000 meters. In 1 minute, it will cover how much distance? 3000 meter by 60. So you get 50 meter. In 1 minute, it is covering 50 meters. Yes. Puneet. Okay. You left. Acha. Okay. So Puneet, what we are doing here is, first of all, I'm repeating it from the beginning. I know that it's a tricky one. So we have a cylindrical tank over here, right? Cylindrical tank, and its dimensions is given. It's 10 meter in diameter, 2 meter deep. So radius would be what? 5 meter, and height is what? Height is 2 meter. So we are filling this cylindrical tank with a pipe, which is also cylindrical in shape. So this pipe has a diameter of 20 centimeters. So we can find out the radius, and that we will find out in meters. Okay. But we do not have its length. We do not have the height here. Why are you converting? Because half of the question is in centimeter, half is in meters. So the unit have to be same throughout, right? Yes. Okay, so what we are doing here is, first of all, we will find out the radius for the circular pipe. That's going to be 0.1 meter. You can find out the radius. That's simple, right? You divide it by 2 and you divide it by 100, because I have to convert the units also. So what we are doing here is, first of all, you need to find out. See, forget about the area of cross section if you don't want to find it. That's okay. We have its radius over here, right? That's what? That's 0.1 meters. But I need the volume, because it all depends. If I have a bigger pipe, it will take less time to fill the cylindrical tank. If I have a smaller pipe, a narrow one, it will take more time to fill the tank. So the time always depends on basically the object from where the water is actually flowing. Yes. So what I'll do here is, yes, it's okay. I'll explain in English also. Yeah. So basically cylindrical tank को आपको fill करना है. जो आपके पास pipe है, that is also cylindrical, right? But वो pipe के dimensions पे depend करता है, whether it is a broader one or it is a narrow one, right? उस पे depend करता है कि कितना time लेगा उसको fill करने में. So आपके पास इसका radius given है, but you do not have its length, you do not have the height. How would I find it out? Question says the water is flowing at the rate of 3 km per hour. That means in 1 hour, the water is covering a distance of 3 kilometers. Obviously, along the length flow karega. Makes sense? Yes, Sonali, that's fine. Even if you're converting into meters. Yes, I converted into meters only. That's right. Can we do the math first? After that, we convert it. No. You have to convert first. first conversion needs to be done, then only you can equate them. Otherwise, you cannot equate them. We equate something when the quantities are exactly same. Yes, Dilip. So cylindrical pipe है, cylindrical tank है. Cylindrical pipe से water is flowing. Yes. But volumes को how will you equate? Simply what we are doing here is, let me just tell you the final thing first. So the time that the tank, in which the tank will be filled, let's say that time is, let's say, I'm finding it in minutes, let's say that's X minutes. So that time, it completely depends on that cylindrical pipe, right? So volume of water that flows through the cylindrical pipe. Volume of water that flows through pipe. That would actually be equal to volume of the cylindrical tank. Is this step clear to all of you? If this is clear, you would understand the entire question. Yes. Anonymous 007. Yes. Quickly. Okay. So जिस पाइप से पानी जा रहा है वो भी सिलेंड्रिकल है, जिस टैंक में आ रहा है वो भी सिलेंड्रिकल है. नाउ इट ऑल डिपेंड्स. जिस पाइप से पानी जा रहा है अगर वो नैरो होगा बहुत टाइम लगेगा सिलेंड्रिकल टैंक को फिल करने में. बट अगर इफ इट इज ब्रॉडर इट विल टेक लेसर टाइम टू फिल द सिलेंड्रिकल टैंक. Yes. No, Varuna, you cannot call it a formula. It's basically a concept. Don't mug up things. Yes. So what we are doing here is, I'm assuming, I don't know how much time it will take. I'm assuming that to be X minutes. Let's say it will take X minutes to fill that cylindrical tank. So that time, I don't know whether it will take 30 minutes, if it will take 45 minutes. It all depends on the volume of that cylindrical pipe. So that's why I'm multiplying that time with the volume of that cylindrical pipe. So the entire amount of water that flows through it in that span of time, that would give me the volume of water in the cylindrical tank that is to be filled. Yes. Yes, yes, yes. I hope this is clear now. Yes, Eric? Quickly, Girija understood? Yes. Puneet? Nitik, okay. We will check what the final answer is. First, let's understand the concept. I hope everyone has understood this much part. Okay. So, all right. So this step is clear. Now, what I need is, we have the volume of the cylindrical tank because we have the diameter, we have the height. But I need to find out the volume of this pipe. So how do I find it out? To find out the volume, I would require its radius, which we have. I'll convert diameter into radius. But first, you need to convert that into meters. And I need the height also. So what is the length? That is basically, I told you, that's 50 meters, right? So pi r1 square h, right? Or h1, let's say. Pi will remain as it is. What is radius over here? Radius is 0.01, right? Radius is 0.01 square into 50. Or is it square or is it 0.1 something? Let's check. It's 0.1, right? So radius is 0.1 square into 50. You get what? You get 0.5 pi meter cube. Yes. So we have the volume of water which flows through that pipe in 1 minute. In 1 minute. Now all we need to do is simply, let's say that it takes t minutes to fill that tank. So t minutes into the volume of that cylindrical pipe that we have, that would be equal to the total volume of water that flows in t minutes into that cylindrical tank. So we are just equating their volumes, you see, and you get 100. Yes. Right, versatile mates. Yes. We are not finding out the speed of water. We are finding out the time in which the tank be filled. But always remember one thing. In such kind of questions, it's a trick. You can convert this speed always into length or height, whatever you can say. Yes. Always you can try such kind of questions. There is one or two more questions are there in the NCERT just like this. And for practice also, you can use any of the reference book also. And you will always see this is one of the trick that I use, that you can convert the speed into length or height to find out the volume. Yes, I hope this is clear to everyone. Yes, all right, Puneet. Yeah. Great. So we are done with all the questions, all the 10 important questions. So now instead of going through the entire surface area volume, you can just practice these 10 questions. I've covered all the important ones. Now homework time. So a solid toy is in the form of a hemisphere surmounted by a right circular cone of same radius. The height of the cone is 10 centimeter, radius of base is 7 centimeter. Determine the volume of the toy and the area of colored sheet required to cover the toy. Pi is given, root 149 value is given, and this question came in CBSE 2022 also. This is also an important one, and you can solve this and let us know the answers in the comment section. All right. All right, and don't worry, we have got you covered because there are so many sessions that are lined up for you from every Monday to Friday to make you exam ready. Now, let me give you a glimpse of the upcoming session. So, next session is on March 21, that is Monday at 7 p.m. I'll be discussing 10 most important NCERT questions of statistics. Somebody just said that in the session today that you have doubt in statistics. Yes? So, on Monday, I'm coming up with this session so you can get all your doubt clarified during the class. Yeah. And you know that we have got free trial classes as well. Link is there in the description. You can click on that and get all your doubts get clarified instantly during the class. And please like, share and subscribe so that you do not miss any new updates from us. And I wish you a very happy and safe Holi. Yes? Yes, thank you, Puneet. Yeah. Thank you, Aditya. All right. All right. All right. So wish you all a very happy Holi. Yeah. Same to you. Yes. Thank you. Thank you. So I'll see you on Monday. Yes, you can watch that session. It's there on YouTube. Thank you so much. All right. Happy Holi and I'll see you soon. Thank you. Bye-bye.